is like one step further. But this is my architecture, even though we haven't really applied this in production. More contextual-based, targeting. So this is the same user. Let's say this is myself. This is the same graph for myself. But if you can observe, contextual information, for example, the behavior at weekend and weekday is probably different. So I probably read more about sports, over the weekend, but on weekdays I probably read more finance-related or whatever news or technology-related news. So this graph is actually dynamically changing. Like the weight or the color here are actually changing based on different contexts. So like what you read, during the evening, bedtime, and at work are also different. Right? So this is how WeChat does it. They have amazing data. So pretty much they collect a lot of data about you. This is how they do personalized recommendation. In WeChat, they recommend probably like news, content, they recommend music, or they recommend things you can buy, right, if you use a scan code. They collect, for example, the web pages, if they have location data, but also like the weather information, whether it's raining. If it's raining, they may want to show you different kind of ads. Probably you're staying indoor, location data, some real-time behavior data. And they're not really using very sophisticated algorithms. A lot of people are talking about deep learning or neural networks. But they run a distributed logistic regression on Spark. They also own the biggest Spark cluster in the world right now. I think 8,000 nodes, but that was like from last year. Again, all of these attributes or taste profiles they collect become like one of the features in their model. So this is very high dimensional. You can probably have like hundreds of thousands of features or attributes in your model. This is actually where like tools such as SAS will break down because it doesn't handle this kind of high dimensionality very well. They train that on Spark, but logistic regression is easy because when you want to apply the model in production, it is just weighted average. So this is what they use. Most companies such as Facebook also use logistic regression. Even Google use that. YouTube do like a video recommendation. They train logistic regression model on billions of features. So this is why actually they use like technologies such as Spark and MapReduce. Right, that's about the user profiling. Once we have a user profiling, how can we use it? So one of the use cases I'm going to give you today is you can use that for online behavioral targeting or real-time bidding. This is how actually you get all the ads. If you go to a website. Why big data matters here is the velocity and the volume. So each ad you see need to go through a type of like a real-time bidding process. So if you go to a news website, you see like 5 different ads. But these are actually the 5 ads. There are a lot of bidding and machine learning scoring going on in the back end. And the server, the system will decide like these 5 ads will be most relevant to you. And it all happens less than 200 milliseconds. For that to happen in like 200 milliseconds, your data is actually traveling through a lot of servers. So you go to your web browser, you go to CNN.com website, you have a page request, so that information, the session information is sent to the publisher, right? Let's say it's Forbes or CNN. They're actually going to send, because they want to show you some ads, and they're making, this is one of their revenue. So they're actually sending your data across the network to all the ad exchanges or ad networks. So these are each individual companies. Google, DoubleClick are here, Facebook Exchange here, YouTube. There are a lot of private ones. The example here is a company called Rocket Fuel. They're actually #1 private ad exchange. They're the biggest one right now, I believe. So your information is sent to these ad exchanges. Each one of these company, they will have their sophisticated bidding and machine learning algorithm. So let's say this is Rocket Fuel's example. They get this request. I want to show this some ad to this user. Receive the bid request and send this information to their backend server. They train a lot of predictive modeling, probably hundreds of models every day. they calculate perplexity, like, in their database they can have 500 or like even 5,000, even more ads they can show to you, but they can only decide which, like only 1, 2 to pick to show to you within like, a few milliseconds. So the machine learning happens here, all the scoring, and they pick the best ad. And then they are going to bid for it, because there are a lot of competitors. They're all willing to pay. Somebody is paying like 5 cents, someone is paying $10. Probably that person paying $10 is going to win the bid, and so that he can show the ads to this user. So it's a little bit optimization and game theory as well. They have to guess the price. I know this user is going to like this ad, but I also don't want to pay too much for that. This is one example. So.
That was the word is a cake. The company like a cake.
Kik is not doing any advertising, but we did advertising at BlackBerry. BlackBerry BBM is also a social messaging app like WeChat. So what my team does is providing the user profile, because each decision making happens in 200 milliseconds. You need to make a decision. This is the information I know about this user. Is he going to like this ad? How likely he's going to click on this ad? And then you're going to bid for that. Yeah, so this is what we, and if it's a company such as Kik or Facebook or BBM, they are publishers because they provide content. So they have users, they collect user information, but then they are probably going to send the user information to some external ad exchanges, because we don't run the advertising business ourselves. We only have user and audience, and advertisers are actually paying and competing for the users we have. Yep. All right, so this is one click-through prediction example. Let's say Rocket Fuel receive, they have potentially like a couple of hundred ads they can show to this user, but they can only select one. So they have user profiles such as location, context, but then free ads here, they will have the scoring. So on their scorecard, they will say, this user, based on his attributes, demographic, his time of day, usage, he's more likely to respond to this boost-related ads. So this is going to win internally, and then they are going to send this to the external ad exchange, and they are going to bid for that. So they may win. If they win, then this ad will be shown to you. But maybe they lose that to Facebook. Probably Facebook has a better model, or they pay more for that. Okay. So this is how real-time bidding works. In a big data context, they have a lot of ad serving servers in many different data centers. They operate globally in 8 different data centers, because if the ads he's showing to, if they operate in the US, but someone is viewing their website in, like, let's say in China, obviously there's like network transfer latency. So they have to make sure that each continent they're probably going to have a data center, and then they collect real-time data like user events, pixel streams, and ad logs. They have a Hadoop system. It's based on Hadoop and HBase. So all the model trainings are offline. So they have all the big data here. They process like 40 million biddings, real-time biddings every day. So they have a lot of data. Model trainings, they happen in probably Spark or Hadoop. And then they create behavioral targeting features in real time and put them in HBase. And then the scoring happens in real time, and they will decide which ad to show to the user. All right, so that's the use case. I always like to start by talking about use case before we talk about big data. But now we can move on to talk about some of the trends and opportunities and some of the lessons I learned in the last few years doing data science. Again, I won't say myself is an expert, because the more you deal with this, the more you realize that a lot of things you don't know, because you only have limited amount of energy and time. So normally data science is considered to be a team. It's not like an individual unicorn or something. So a lot of people would like to talk like the 4 V's or 5 V's of big data. One example I'm giving here is the velocity. Okay, so I know there are a lot of very seasoned IT professionals here. You probably know how to build a mobile application. If you look at the retention curves for Android apps, this is how they retain their customers over time. And you realize that even the very best apps, for example, those rank among the top 100 apps in Android store, they lose probably 50% of their user base on day 1. So they download it, open it, try it, they don't like it, they stop using it. So a lot of the goal or optimization for the business is trying to lift this curve. So if you can go up here, obviously you have a better retention curve and you'll make more money. And definitely you're going to grow. But then, again, comparing that to like campaign optimization management application in a banking system, because for mobile applications, probably there's less switching cost. I download it, I don't like it, I stop using it. But for banks, there you have to go through that process. You have to deactivate. You have to create a new account with another bank. So the action to speed is much the demand for that is much higher. So you have to do something in real time, or maybe like for onboarding on the first day. My prediction for the future, it is actually happening right now. Personalization is going to be a key differentiator. If you're going to build mobile application, you have to think about like personalization early on. But personalization is easier said than done. Okay? After the Netflix competition in 2007, there are a lot of new algorithms coming out like every year. A lot of research papers published. Actually, running a recommender system algorithm is like very easy today, but getting it done right is actually not that easy. So good algorithm is only part of the story. Sometimes it's a matter of like how you can actually rank and filter the data. Good models, you can have. I highly suggest like statisticians or data scientists don't get too obsessed with your model, because you can build perfect model, but your communication skill is poor. So your product managers don't get your idea. They don't even know how to build all the good features or like apply your model in their product. Then you end up having some bad UI design, or they just don't get how to apply your model. And then even if you have a perfect model that evaluates very well, it's not going to work in reality. Obviously, good architecture is key, because if you want to do personalized recommendation, you want to give the recommendation under 50 milliseconds or 200 milliseconds, you need a very good architecture for that as well. So it's not just about the model. And sometimes it's the science and art behind measurement and A/B testing as well. I see the trend of moving, a lot of enterprises moving to the cloud. A lot of people say, cloud is only for the startups, but actually, a lot of big companies are actually moving to the cloud, and it's happening very fast. So, one example, well, this is not a big company, but they are pretty huge right now, but this is one example of Airbnb. Their infrastructure is completely based on Amazon Web Service. The number one reason people adopt cloud is it's very agile. So when you just started, you only have 5 people on the team. How are you going to assemble like an IT department? You have your own data center. You don't even know how many customers you're going to get in 5 months. So you can always start small. So normally startups get started either on Google or on Amazon. So back in 2013, they only had 4 million users. But a year and a half later, they have 15 million users. If you're going to have an IT department, it's even hard to estimate how much investment you need upfront. How many servers you need to buy, those are hard to guess. Also see the trend of moving from infrastructure as a service to like a lot of companies actually doing like big data as a service. Oh, by the way, one amazing thing is they have tens of billion users. They only have a 5-person operations team. It's hard to imagine for a company such as BlackBerry, because you're probably going to have like 20 or 50 people. Even paying for the salary is like millions of dollars. So they're moving really fast on the cloud. They're getting a lot of great endorsement. I was at the Amazon reInvent conference last month. Beginning of this month, there are like 20,000 like IT professionals attending that conference. GE, they had thousands of microservices. They are migrating the majority of them to AWS. Capital One also did some interesting stuff on AWS. And Accenture, as a IT consulting firm, they are also saying that they're going to put a lot of effort into AWS. So they're going to train their professionals how to use AWS to build their big data solution on top of the cloud. So they probably have a lot of job postings too. And another trend is machine learning as a service. So truth be told, a lot of people think that machine learning is hard. It is hard if you're in academics because you need to publish paper. You always need to build something better, right? So this is the flow. You got some data for research. You build your machine learning algorithm, and you're trying to compare. So, oh, my curve is better than your curve. Great, I can publish a paper. But in reality, that's not true. Machine learning prediction as a service is getting more and more popular. Companies such as IBM, Microsoft, they have like extreme machine learning. Amazon even offers, even though they are not very strong in software as a service, they do have some very basic Amazon machine learning tools that makes building a model so much easier than before. And those are built for like software developers because you probably are not trained statisticians, but they allow you to build models at scale. But the hard part about machine learning is how do you build scalable systems, right? How do you handle all the spikes? All of a sudden you have like 500,000 more users. How do you handle latency? How do you do the model serving in real time? How do you monitor and testing your system? And a lot of applications are context-driven in the future. So these are the hard part. Actually building a model that piece is not as hard as before, I would say. And I think big data is also changing the way we do data science. We think about data science, we approach data. So it changed.